Well, a familiar sight, everyone. We're taking a live look right now over Yellowstone National Park. I know you're probably looking at your screen and going, well, that doesn't look like Boston. But there's one thing I want you to notice in the shot right here, and that is this. That is snow, believe it or not. And as a matter of fact, earlier on this week, they saw upwards of a dusting of inch to almost an inch in some places of snow in portions of Wyoming, all that area over there. So yes, it is coming. And it was actually rather chilly this morning. Some places dropped down into the 40s. Right now we're 70 degrees in Boston though. Beautiful sunny day, and tonight, no exception to the rule, 58 degrees under very moony skies. I guess you can't really call it sunny, so moony is a default in that case. And tonight the harvest moon is coming up as well. So that is something that will be pretty cool. We'll have more on that in just a moment. In the meantime though, this is where we started. Look at all the blue on the map. We start very, very low in terms of the temperatures. We're bounding a little bit in the afternoon, all thanks to the intense sun, but the sunsets are getting earlier and earlier every day. In fact, we're before 7 p.m. for the sunset, which is pretty darn depressing. But how low did we go this morning? Well, I want to show you some of these low temperatures because we were very frigid, almost frosty, pun intended, if you get the chance. 55 degrees in Boston for the overnight low. However, out in Taunton, 40 degrees, New Bedford 43. Once you got away from the city, didn't have all that pavement holding on to the heat. So it started very, very low. And strangely enough, the Cape, which is normally a little bit warmer, they were the cold ones this morning, colder than everybody else. For instance, 43 degrees in Falmouth, 44 in Hyannis, dropping down to 38 on Martha's Vineyard simply because they are a great radiator, giving away all that heat. We didn't have any blanket or cloud cover last night to hold on to the heat, so that's why, since we have the dry air in place, all the heat just radiated outward into space. I want you to notice this though. This is Julia. She's spinning off the coast. If you looked at radar maps of the Carolinas over the past couple of hours, you probably haven't seen all that much going on just because the majority of the moisture is offshore. But it's not that far away. Some of that moisture is going to be pulled into our forecast over these next few days. However, I want you to pay attention to tonight because you saw those clear skies over us. You'll be able to see the full harvest moon. Of course, not to scale. I tried to make a nice little graphic, but it's going to be full tonight. The harvest moon is coming up at 6:59 p.m. Just look east, and it will look a little bit bigger than other full moons too because it is one of the closest approaches to Earth in terms of the moon. The lows tonight, 55 in Boston, 52 in Plymouth. Again, the Cape radiates a little bit better than everyone else, so they're going to cool off a little bit more than the rest of the area. However, the cold doesn't stick around all that long. See this big warmth bubble of heat, I guess you can call it, building to the south? Well, that pushes up ahead of the next warm front, but cold front drops down very quickly from Canada, and as it does so, it's going to give us a chance of seeing some showers and storms. The winds turn around to the west behind it, pumping the cooler air. And I want to show you some of the impacts because right along this front, it's tough to tell right here, but these are all forming along a line associated with the cold front. So that's going to move in later on tomorrow into tomorrow night. And that's why I see right here, this is going to show you out in time as these showers begin to bubble up. Not all that impressive, however, starting tomorrow. Sunday is going to be the day when we have to watch these stronger showers and storms. Couple could produce some gusty winds, a very, very low risk of an isolated spin-up tornado simply because there's a little bit of wind shear out there. But I think the best chance is going to hold off through Sunday. Early Sunday night into Monday morning is when we're going to see that. However, there's going to be a plume of moisture working up the coast, so I can't rule out a little bit of an influence from Julia just in terms of the moisture. How much moisture are we going to see? Well, most of us, less than ½ inch. Couple places down towards the Cape and the Islands in extreme western Mass, I have to do kind of a dance here, are going to see up to an inch. I think that's going to be the extreme, maximum. Don't think that's more than, the exception rather than the rule. However, we desperately need the rain. Most of our area is under extreme drought right now. Almost 3/4 of Massachusetts seeing that. We've only been about 22% in the past couple of weeks, but now we're well over half, and that is just scary to see. We only saw 3.92 inches so far this summer. What we really need is a tropical system, and we're just not going to get one. There are plenty of them out there, though. Take a look at the Atlantic right now. Here's Julia. She's moving northeast-south, or rather east-southeast at about 7 miles per hour. Winds of 40, but across the entire Atlantic basin, look at all the stuff that's going on. You have Ian. Oh, Ian's over here. Carl's down here. All sorts of stuff. So it is rather busy. But in the meantime, we have our 7-day forecast to talk about. Check it out. It is going to be a nice couple of days through the first half of the weekend. So if you have any weekend plans, I try to squeeze them in on Saturday because by the time we get to Sunday, that's when we begin to introduce the clouds. I don't think the day's a washout. I actually think it's pretty nice. Evening into overnight, those showers and storms. Monday, they linger, clearing up in the afternoon. Tuesday, could be some reminiscent clouds, but those are going to burn off quickly. 81 degrees for the high. And then Wednesday and Thursday of next week, we're still stuck in a fall-like pattern for dryness, but a summer-like pattern for warmth. That is my latest forecast for now, but we'll be right back after this break. And welcome back. We're going to be talking tropics today because we've had all sorts of stuff going on. As you saw in the last segment, we have at least 3 named storms in the Atlantic. That is the first time we have seen that, actually, since back in 2012 rather, with Isaac. There was Isaac and a couple other storms in the Atlantic, and it was a very busy season then. I want to show you this, though. This is an absolutely gorgeous, albeit unfortunate picture of Typhoon Moranti as it headed out in the Pacific. And this is pretty cool because you can see it spinning right here, but this is 1 minute and 1 kilometer resolution we frankly haven't seen before for a very long time, and it is just spinning around. But if you look in the eye right here, you can actually see miniature low pressure swirls within it. And the cool part is, if you take a look, I'm going to back it up again so you can see, all these mini low pressure systems within the low is characteristic of how low pressure generally behaves, lows within low, and it is so cool to see. You can almost see it like centrifuged around. Over here, I want to point out another feature, if I can back up the video just a little bit. All this, see right here, this is kind of a cold front starting to form with convection trailing in, but you see it moving all the way in here. And the neat part with hurricanes is that it has to be a perfect balance between the Coriolis force, which is how it gets its spin, the pressure gradient force, which is a result of the extreme changes in air pressure across the system, and then in addition to that, we have the centrifugal force. Think of about going around a merry-go-round, and you're forced to the edge. So all of those combine to produce this perfect balance of winds to give it its beautiful structure. You can see waves rippling out, and the cool thing is, as air is sucked into the storm, it begins to rise and will actually spread out. So there's almost a high pressure system above that. However, we're not out of the woods in terms of our tropical systems. I want to show you this. You've seen Julia down at the Atlantic, okay? We're going to do some real forecasting for you right now because one thing I'm concerned about for this weekend is what's called PWAS, or precipitable water indices. Basically, if you go up in the atmosphere, how much water is there for us to work with? And this weekend, there could be a fair amount. This is showing you some values in excess of about, looks to me like almost 2.5 inches. We're going to refresh it again. So let's see, if we go right down here, we're going to use a NAM, one of my favorite models, switch to northeast. And I want to show you this right here. So if we go to supplementary products, well, let's see, precipitable waters. Okay. Oh, yes. So precip accumulation, that'll show us. But yeah, so you can see quite a bit swirling up. This model doesn't really show it all that impressive, but when we switch to the GFS, the United States model, and do the same exact thing, go to precipitation products, I want to show you precipitable water indices, which is right here. And this is really cool because as you see right here, blues, couple purples too. And notice how they become a little bit more intense right here in eastern Massachusetts. This little narrow curtain of some purples. Those are representing values of in excess of 2 inches, meaning if you were to go up in the atmosphere and squeeze everything out, there would be 2 inches of water over the entire state of Massachusetts, which is kind of alarming. So what I'm worried about happening is called a predecessor rain event. Basically what happens when a tropical system's surge of moisture works with an approaching cold front, which is right down here, and squeezes out the moisture just like wringing out a washcloth. So that's why, even though the forecast is only for a little bit of rain, it wouldn't take much if this surge moves us a little bit farther westward for us to get in on some significant rain totals. Not looking likely at this point, but the potential is there, and that is one cool thing to see. In addition to that, I briefly want to talk about GOES-R. It's a satellite that shows just what we were seeing a minute ago in terms of just how beautiful Moranti was. So Moranti was that typhoon over there. GOES-R is what's going to happen in the next couple of years. It's going to be launched late 2017, early 2018. It will have that kind of resolution. It's the equivalent of going from like a black and white TV to full HD. So it's going to be huge for the meteorological community, and that is one cool thing to see. We'll be right back with a little bit on how winds form. Hi guys, I want to give you a little bit of soft serve science because that's not something we talk about all that often. And today I got a really cool question from my grandfather asking, where do winds come from? And frankly, if you've been outside, I'm sure you have, at one point or another in your life, you've seen wind before, and it's kind of cool because you can't see it, rustles the leaves, does all sorts of damage in some places. Yet, it's not something we really know where it comes from. So the cool thing is, I want you to visualize this. Imagine going to like the Hoover Dam or some sort of big dam, and on one side, there's an extreme amount of water, very, very high. On the other side, there's absolutely nothing. Now, of course, gravity is pushing the water down, but what would happen if the dam were all of a sudden to break or you to lift it up? Exactly. The water would rush halfway through and kind of level out, and that's kind of what's happening with air pressure. So there are times when it might be cold, might be sinking air, but what you have happen is basically all the air begins to condense, sink, concentrate, and produce an area of high pressure. That's why up by the poles it tends to be very, very cold and dense high pressure. When it's warm, sometimes the air expands a little bit less dense, so you have an area of high pressure and an area of low pressure. What happens though, the wind, air, tries to balance itself out. It flows downhill, kind of like with the dam. The fluid goes from high pressure to low pressure, and that's how you get winds. Now, coming up in just a moment, we're going to talk a little bit more about, and you can find this online rather, a little bit more about where the winds not only come from, but why they rotate in low pressure systems. It's kind of cool.